Hi everyone, we're Team Rootwise, and this is Swarm, an urban operations agent built for real-time city fleet coordination. Toronto's waste collection still relies heavily on fixed routes and schedules, but city operations are never fixed. A truck may run a half-empty route while another area is overflowing. A construction closure, traffic accident, protest, severe weather event, flood, or emergency alert can completely change what the best route should be. The problem is that waste collection today is often reactive, and the operators often respond after something has already gone wrong. Our solution to this is Swarm, an agentic AI system that helps Toronto waste collection move from fixed scheduling to real-time adaptive operations. Swarm is not just a dashboard, it's a background operations agent. It receives city data, understands the current fleet state, evaluates real-time events, and makes operational decisions. If the situation is too uncertain or requires human judgment, Swarm escalates the decision to an operator through a human intervention interface. For this hackathon, we use the Open City of Toronto data, including waste collection schedules, service zones, population distribution, road data, and 311 service requests. Because municipal fleet data is not publicly available, we built a simulation layer that generates realistic mock events, including overflowing bins, missed pickups, road closures, weather disruptions, protests, accidents, construction, truck capacity limits, and driver availability issues. On the left, we start with the public operational data, things like routes, traffic conditions, service schedules, and city process rules. That data feeds into our event simulator, which creates realistic disruptions such as overflowing bins, delayed trucks, road closures, or capacity issues. Static data like maps, holidays, and fixed service zones branches from the same data pipeline and feeds directly into the agent as context. The simulator can also overwrite or update static assumptions when a new event changes the operating environment. For this specific demo, we use a simulator, which will be simulating different types of mock events. However, in a real-life scenario, we will be using the real-life data and real-life scenarios that will be fed directly into the agent as context. Inside the workflow, the brain is a reasoning layer. It takes the event plus the context, decides what action is needed, and then calls the right tools. OR tools handle the route and fleet optimization, Report HQ escalates the uncertain or high-risk cases, Message driver communicates instructions, and Update GUI pushes the decision back to the operational interface.
Okay, we want to introduce our AI operation command, which is called span. You can see for our UI, we have a brief introduction. For first part, we have a search bar. You can type any address code, area code. We have a 10 area code. We have a 10 area code right here. This is what we have right now for data. We are using the real data from Toronto government. For on the right side of our UI, you can see there's a time right here. There's about weather. A live Toronto map. As you can see right now, it shows like MSG, which is downtown Toronto. 311 YTD is all the complaints from the 311. This is also the official data from the Toronto government. We download the data process to make them to process to become the demand of the waste we have to collect. Also, right behind it, there's a truck route plan, which is telling you how our daily routine, how the truck is going to collect the waste without any incidents or emergency happens. So let's see, on the left side corner, we are playing an agency autonomy active right now. So let's make an example. Let's make a random address. Let's say we have a M6E right here. If we zoom in, we can see that there is the original route plan right now. For the orange, it shows for truck 2 and purple for truck 1. We can see right now for truck 1 need 11 minutes and truck 2 need 13 minutes. Let's see what if there's an incident happens. We'll call the agent, which is called bring.py. So let's say we have some incident, right? From fire that is rain. And then you can see there's incident pop up right below the comment of incidents. We can see that it is waiting for rain to process. For us, we're trying to calling the tools. You can see for the first one, over we calling update UI. And there are still thinking. And then also after the incident is processed, it will show on and then give us some reasons. It says like rain affect travel times relative end by 1.0 and travel by 1.2 handled and it's handled. And you can see right now on the collection routines, you can see Truckman actually change everything. They changed from default to 9 to 2 to 1. The default is right now for 9 minutes, and for Truckman right now is 14 minutes. Now let's pop into the screen to see how it's changed the routine. You can see there's a different routine presented. What else? Let's say we have another instance. Let's say there is a parrot showing up. You see there's another event that's happening. It says, okay, for this case, maybe the demand and the travel didn't change. We are also calling the tool, which is called update UI. Let's also see, okay, right now it shows that travel has to be 1.3 after it processed, right? You can see that also the routine has changed, but truck is now right now 10 minutes from 10 minutes, and the truck is right now 15 minutes. For the API, we're using the new code from the NVIDIA. It's really powerful. We really appreciate to have this chance to participate in this for this now. That's it for our platform. And we're going to add more features in it. We'll probably add more live data right now for the weather. Also for the incidents, we probably will lock into the communication system of the different drivers combined with the HAT system of the Toronto waste collection government. That's it.
Swarm directly supports the urban operations track because it improves how the city runs behind the scenes and in real time. By making waste collection adaptive, Swarm can reduce fuel waste, improve truck utilization, reduce mixed pickups, lower emissions, and help operators respond faster to disruptions. The long-term vision here is much bigger than just the garbage trucks. The same agentic operations framework can be extended to snowplows, road maintenance, street cleaning, emergency logistics, and other municipal fleets. Toronto does not need another static dashboard. It needs an intelligent operations layer that understands the city as it changes, makes decisions in real time, and brings humans in when needed. That is Swarm.